Welcome to DT tutorial. In this video, we're looking at electrolysis. Electrolysis. So what is electrolysis? Electrolysis is the chemical decomposition of a compound in its molten state or in solution when electric current is passed through it. It is the chemical decomposition of a compound. That is, it is the chemical breakdown of a compound. So it is the breakdown of a compound in its molten state when a compound is in its molten state or when it is in solution. And what will bring about the breakdown? It is when electric current is passed through it. So there are three main things here. It is the chemical decomposition of a compound, and the compound must be in its molten state or solution when electric current is passed through it. So that chemical breakdown of a compound in its molten state or in solution when electric current is passed through it is what is known as electrolysis. So for electrolysis to occur or for the compound to be decomposed, it has to be in its molten state or it must be in solution. So again, electrolysis is the chemical decomposition of a compound in its molten state or in solution when electric current is passed through it. And the process occurs in what we call an electrolytic cell. So the chemical decomposition of a compound in its molten state when electric current is passed through it occurs in the electrolytic cell. And this is the structure of a typical electrolytic cell. It is composed of the battery or the cell, and this is the battery, also known as the cell, the cathode, which is the negative electrode, and the anode, which is the positive electrode. Then we have the electrolyte, which is the molten compound that helps in conduction of the electric current from the battery. So these are the four major parts, or rather three major parts of the electrolytic cell. So the three major components that we've looked at are the electrolyte, the electrodes, which is made up of the anode and the cathode, then the battery, which is also called the cell. So this is the battery, also known as the cell. This is the anode, which is the positive electrode. This is the cathode, which is the negative electrode. And this is the electrolyte. So these are the three, or rather four major components of the electrolytic cell. So the first one that we have here is the electrolyte. Electrolyte is the molten compound which conducts electricity and is decomposed at the electrodes. It is the molten compound. Electrolyte is the molten compound. So it is the compound in solution, and it has to be a compound, not an element. So a molten element cannot be considered to be an electrolyte. So electrolyte is the molten compound which conducts electricity and is decomposed at the process. So like I said, this is the battery of the cell. Once the battery is connected, electric current will flow into the electrolyte through the anode, through this positive electrode. And once the electric current enters into the electrolyte, it is conducted to the cathode. So it is the electrolyte that is responsible for conducting the electricity from the anode to the cathode. So it is the molten compound which conducts electricity and is decomposed at the electrode. So during the process of electrolysis, the compound, the molten compound, which is the electrolyte, will be decomposed in the process. It will be broken down in the process. So this is the electrolyte. Electrolyte exists in three major forms. It can occur as an acid, as a base, or as a soluble salt. So examples of acid electrolytes are tetrasulfur 6 acids and triazonitrate 5 acids. There are other acid electrolytes as well. Then we also have the alkali. It can occur as an alkali, and examples of electrolytes which occurs as alkali are sodium hydroxide and calcium hydroxide. Then examples of electrolytes that occurs as soluble salts are copper 2 tetrasulfur 6, then sodium chloride. So these are the various forms of electrolytes: acid, alkali, or as soluble salts. So having known what the electrolyte is, let's look at the next component of the electrolytic cell, which is the battery. So the battery, the main function is generation of electricity. It helps in generating electric current. So once the battery is connected, electric current is generated, and that current flows into the electrolyte through the anode, and from the electrolyte it goes into the cathode, and then the current is conducted out. So the main function is just for the generation of electricity or electric current. Then the third component of the electrolytic cell that we have here is the electrodes. And like I said, the electrodes are in two forms. We have the anode and the cathode. The anode is the positive electrode, while the cathode is the negative electrodes. So the electrodes, they are conductors through which current and electrons leaves and enters the electrolyte. They are conductors through which current and electrons enters and leaves the electrolyte. So this must be noted. The two main things that enters and leaves the electrolyte through the electrodes are current and electrons. So it is through the electrodes that current and electrons enters and leave the electrolyte. So the positive electrode is known as the anode, while the negative electrode is the cathode. So this is a pictorial example or pictorial representation of this. This is the anode, the positive electrode, and this is the cathode, the negative electrode. So one important thing to note here is that as the battery is connected, once the battery is connected, current will enter into the electrolyte through the anode. So current will enter into the electrolyte, into this setup through this anode. So the current that flows from the battery goes down from here, down into the anode, and from the anode it enters the electrolyte. And the current will leave the electrolyte through the cathode. So current enters through the anode, while the current will leave. The current leaves through the cathode. So the current that has been conducted into the electrolyte via this anode will leave the electrolyte through the cathode. And one more important thing that occurs here is that as this process is going on, the electrons will enter into the electrolyte through this cathode, and they will be conducted out through the anode. So electrons will enter through the cathode, and the electrons will leave through the anode. So this is very important. Current enters through the anode, electrons leaves through the anode, current leaves the electrolyte through the cathode, and electrons enters it through the cathode. So these two basic things, they are very important. So just a quick recap. The electrodes, like I said, are made up of two, or they are in two forms. We have the anode and the cathode. The anode is the positive electrode, while the cathode is the negative electrodes. And as we've said, current enters the electrolyte through the anode, electrons leaves the electrolyte through the anode, and oxidation as well occurs at the anode. Oxidation occurs at the anode because there is loss of electrons from the anode. Oxidation occurs at the anode because the anode involves loss of electrons, or electrons leaves the electrolyte through the anode. So oxidation in terms of electrons, oxidation is defined as loss of electrons, and like I said, it occurs at the anode. Reduction is the gain of electrons, and it occurs at the cathode. So just as we've described before, electrons will enter into the electrolyte through the cathode. So electrons, they enter into the electrolyte through this cathode. So the cathode is going to gain electrons, while the electrons that has been conducted into the electrolyte, they will leave the electrolyte through the anode. So it is through the anode that electrons are lost from the electrolyte. So the electrons that has entered into the electrolytes, they will leave the electrolyte through this anode. So oxidation will occur at the anode because it involves loss of electrons. The electrons are conducted out, so oxidation will occur here, while reduction will occur here because there is gain of electrons, or because electrons are entering into the cathode. So this is very important. Oxidation occurs at the anode because of loss of electrons, while reduction occurs at cathode because there is gain of electrons. So anode is the positive electrode. Current enters the electrolyte through the anode, and it is through the anode that electrons leaves the electrolyte, and oxidation occurs at the anode. Oxidation occurs at the anode because it is through the anode that electrons are lost from the electrolyte. So oxidation is going to occur there. Oxidation, like I said, is the loss of electrons, and it occurs at the anode. So oxidation will occur at the anode because of loss of electrons. Then we also have the cathode, which is the negative electrode, and current leaves the electrolyte through the cathode, electrons enters the electrolyte through the cathode, and reduction occurs at the cathode. So reduction will occur at the cathode because there will be gain of electrons at the cathode. Gain of electrons. So just as I've explained here before, that electrons enters into the electrolyte through the cathode. So, and cathode is the negative electrode, anode is the positive electrode. So reduction will occur at this negative electrode because of gain of electrons. So reduction occurs at the cathode as a result of gain of electrons. It is through the cathode that electrons enters into the electrolyte. So these are very important. So before we move further, let's look at this 1996 why question. And the question is, which of the following statement is not correct about the electrolysis? Which of the following statement is not correct about the electrolysis? So the hallmark of this question is, which of the statement is not correct? So the first statement I have here, which is option A, reduction occurs at the anode. Reduction occurs at the anode. Does reduction occur at the anode? So from what we've discussed, oxidation occurs at the anode, not reduction. Reduction is at the cathode. So reduction occurs at the anode is not a correct statement. So this is the correct answer to this option, to this question. Which of the following statement is not correct about the electrolysis? So reduction occurs at the anode is not a correct statement. So this is the correct answer. So even though without reading the other options, I already know that this is my answer. Then the next question I have here is a 2015 why question. And the question is, which of the following statements about an electrochemical cell is correct? Which of the following statements about an electrochemical cell is correct? Oxidation occurs. So you must know that oxidation occurs at the anode. We've discussed that before. And reduction will occur at the cathode. So the first option here, at the anode. Oxidation occurs at the anode. So this is a correct statement. Oxidation will occur at the anode. At the cathode is a wrong statement, or is a wrong option. At the cathode, what occurs is reduction. So option C, through the salt bridge, is a wrong statement. In the aqueous solution is a wrong statement. So which of the following statements about the electrochemical cell is correct? Oxidation occurs at the anode. This is the correct answer. Then the last question I have here is a 2008 why question, and the question is, oxidation takes place at the anode during electrolysis because the anode A is deficient of electrons, B is deficient of protons, C has excess electrons, then D has attraction for positive ions. So like what we said before, that during electrolysis, oxidation will occur at the anode because of loss of electrons. Loss of electrons. And reduction will occur at the cathode because of gain of electrons. So oxidation takes place at the anode during electrolysis because the anode will lose electrons. So because it is losing electrons, it will become deficient of electrons. So my correct answer to this option is deficient of electrons. So oxidation takes place at the anode during electrolysis because the anode is deficient of electrons. It's deficient of electrons as a result of loss of electrons from the electrolyte through the anode. So is it deficient in protons? No. Has excess electrons? No. This would have been true if we were talking of reduction, because during reduction there is gain of electrons. Electrons will not become in excess. So it would have been true. Option C would have been true if we were talking of reduction. Then option D has attraction for positive ions. So this is no. So oxidation takes place at the anode during electrolysis because the anode is deficient of electrons. The electrolytic cell, as we've discussed before, is made up of three major components or three major parts. And the three major parts are the electrolyte, the electrodes, and the battery. And the electrodes are made up of two. We have the anode and the cathode. So this is the battery that generates the electric current. This is the anode, which is the positive electrode, and this is the cathode, which is the negative electrode. And the fluid, the solution we have here is the electrolyte that helps in conduction of the electric current from the anode to the cathode. So this is just the components of the electrolytic cell. Then let's look at the electrolyte proper. Electrolyte, like we said, is the molten compound that helps in conduction of the electric current and is decomposed during the process of electrolysis. Then you must also know that electrolytes conduct electricity because they ionize in solution. So the reason why electrolytes conduct electricity is because of one reason, and the reason is because they ionize in solution. So this is very important. Electrolytes conduct electricity because they ionize in solution. And when they ionize in solution, they form two types of ion: positive ions and negative ions. The positive ions, they are called the cations, while the negative ions, they are called anions. The negative ions, they are formed, which is the anion, they are formed at the anode, which is the positive electrode, while the positive ions, which are called cations, they are formed at the cathode, which is the negative electrode. So cathode is the negative electrode, anode is the positive electrode. So don't confuse this with the cations and anions. Anode is the positive electrode, cathode is the negative electrode. Cations are the positive ions, while anions are the negative ions. So they kind of look opposite. Cation, cat, tode, negative, ion, positive. Cations, they are positive ions, cathode, they are negative electrodes. Cathode is the negative electrode. Anion is the negative ion. Anode is the positive electrode. So you must get the difference between the two. So like I said, the positive ions, they are formed as the cathode, which is the negative electrodes, while the negative ions, they are formed at the anode, which is the positive electrode. Then one more important thing that you should know about the electrolyte is that the higher the concentration of an electrolyte, the higher its conductivity. So the higher the concentration, so this is supposed to be concentration, sorry. The higher the concentration of an electrolyte, the higher the concentration of an electrolyte, the higher its conductivity. So How highly concentrated an electrolyte is, that is how high the conductivity during electrolysis will also be. So there is also something called electrolytes and non-electrolytes. So electrolytes, like we said, is the molten compound which conducts electricity and is decomposed at the electrodes, while the non-electrolyte yes, the non-electrolyte is the molten compound which do not conduct electricity. So they do not conduct electricity and is not decomposed at the electrodes. So electrolyte is a molten compound. It conducts electricity and is decomposed at the electrodes. Non-electrolyte is a molten compound. It does not conduct electricity and is not decomposed at the electrodes. So know the difference. One is a conductor and is decomposed at the electrodes. The other, which is a non-electrolyte, is a non-conductor and is not decomposed at the electrodes. So that's the difference between the two. One is a conductor, the other one is not a conductor. Electrolytes, they are decomposed. Non-electrolytes, they are not decomposed. So, just as we said, an electrolyte is a molten compound which conducts electricity and is decomposed at the electrodes. And examples of the electrolytes, they are sodium chloride, which is also called table salt. We have potassium hydroxide, tetrasulfur acid, sodium trisulcarbonate 4, then calcium chloride. So all these are examples of electrolytes. And from what I have mentioned before, that electrolytes exist in three major forms. So it can exist as an acid, as an alkali, or as a soluble salt. So sodium chloride, which is table salt, sodium trisulcarbonate 4, and calcium chloride, they are examples of soluble salts. While potassium hydroxide is an example of an alkali, tetrasulfur acid is an example of an acid. So electrolyte will usually occur in these three basic forms. It can occur as an acid, as a base, or as a soluble salt. So electrolyte, like I said, is a molten compound which conducts electricity. So all these compounds, they are going to conduct electricity and they are decomposed at the electrodes during the process of electrolysis. They are broken down at the electrodes during the process of electrolysis, and we're going to explain this as we look at electrolysis of some compounds, some basic compounds. So non-electrolyte is a molten compound which do not conduct electricity and is not decomposed at the electrode. So the opposite of electrolyte is non-electrolyte. So the non-electrolyte is a molten compound which do not conduct electricity and is not decomposed at the electrodes. So examples of the non-electrolytes, they are sugar, and basically we're talking of sucrose here. Sucrose does not conduct electricity and is not decomposed during the process of electrolysis. Ethanol, which is alcohol, it does not conduct electricity in its molten state. Urea is a non-electrolyte, does not conduct electricity. Glucose is a non-electrolyte, does not conduct electricity and is not decomposed at the electrodes during electrolysis. Acetone, the same thing, benzene, ether, and trichloromethane. So all these compounds, they do not conduct electricity and they are not decomposed at the electrodes during electrolysis. So this is very important. Conduction of electricity, not conducting electricity, and not being decomposed at the electrodes during the electrolysis. This is what defines a non-electrolyte. So you must know this, that an electrolyte is a molten compound. It has to be a molten compound, not a molten element. It has to be a molten compound in solution. So all these are compounds, not elements. Same with the non-electrolyte. It has to be a molten compound, not a molten element. A compound in solution. And non-electrolytes, like I said, they do not conduct electricity and they are not decomposed at the electrodes during electrolysis. So having known all this, let's look at this 2004 physics jam question. The question is, which of the following is an electrolyte? Which of the following is an electrolyte? So is it paraffin? Is it sugar solution? Is it grapefruit, or is it alcohol? So like we've discussed before, electrolytes occur in three basic forms. So the three basic forms is that electrolyte can occur as an acid, it can occur as an alkali, and it can occur as a soluble salt. So which of the following is an electrolyte? Is it paraffin? It is not paraffin. Paraffins are also called the alkenes. They are a group of hydrocarbons which are saturated with hydrogen. So alkenes, they are not categorized into any of these. They are not acids, they are not alkali, and they are not soluble salts. So paraffins cannot be an electrolyte. So is this sugar solution? It is not sugar solution. Sugar solution, as we've discussed before, is an example of a non-electrolyte. So it will not conduct electricity and it will not be decomposed at the electrodes during electrolysis. Is it grapefruit? Yes, it is grapefruit. It is grapefruit because grapefruit is composed of acids. There are acids inside a grapefruit. So, and we've said that electrolytes occur in three basic forms: as acids, as alkali, and as soluble salts. So, grapefruit contains acid, which means that it will also conduct electricity and it will be decomposed at the electrodes during electrolysis. So, grapefruit is an electrolyte. Is it alcohol? Alcohol is an example of a non-electrolyte, so it is not an electrolyte. So, which of the following is an electrolyte? Grapefruit is an example of an electrolyte, and it is an electrolyte because it contains an acid. And as I've said, electrolytes are usually in three basic forms. It can be an acid, it can occur as an alkali, and it can also occur as a soluble salt. The next question I have here is a 2003 JAM question, and the question is, which of the following is an electrolyte? Which of the following is an electrolyte? So is it alcohol? It is not alcohol. Alcohol is an example of a non-electrolyte. So before we look at the others, like I said, electrolytes occur in three basic forms. It can occur as an acid, as an alkali, or as a soluble salt. As a soluble salt. So alcohol is an example of a non-electrolyte. It does not conduct electricity and it will not be decomposed at the process during electrolysis. Then is it sodium acetate solution? Yes, it is sodium acetate solution. Sodium acetate solution is an example of a soluble salt. It's an example of an organic salt that is soluble in water. So sodium acetate solution is an example of an electrolyte. Is it solid potassium hydroxide? No. Solid potassium hydroxide is not an electrolyte because an electrolyte has to be in its molten state. It has to be in a molten state or in solution. So the word solid disqualifies it from being an electrolyte. Remember from the definition of electrolyte, electrolyte is the molten compound or that compound in solution which conducts electricity and is decomposed at the electrodes during electrolysis. So it has to be molten or be in solution. So this is what defines an electrolyte. So being a solid potassium hydroxide makes it not to be an electrolyte. So is it mercury? Mercury is not an example of an electrolyte. Though it will conduct electricity, it is not an example of an electrolyte. An electrolyte is a molten compound. It's a molten compound. It has to be a molten compound or a compound in solution. So mercury is an example of an element, not a compound. So the correct option to this question is option B. Sodium acetate solution is an example of an electrolyte. The last question I have here is a 2006 JAM question, And the question is, the solution that conducts the highest amount of electricity is, the solution that will conduct the highest amount of electricity is A, we have 0.5 mole per dmq of hydrochloric acid, 2 mole per dmq of hydrochloric acid, 0.5 mole per dmq of ethanoic acid, then D, 2 moles per dmq of ethanoic acid. So ethanoic acid and hydrochloric acid, they will both conduct electricity. Hydrochloric acid is an example of a strong electrolyte. So this is a strong electrolyte. This is also a strong electrolyte. But ethanoic acid is an example of a weak electrolyte. This is also a weak electrolyte. It is a weak electrolyte because it will not ionize completely in solution. Hydrochloric acid, on the other hand, will ionize completely in solution. So the question is, which of them will not be, or which of them will conduct the highest amount of electricity? So with this, we have ruled ethanoic acid out because ethanoic acid is an example of a weak electrolyte. It will not conduct the same amount of electricity as hydrochloric acid because hydrochloric acid, they are strong electrolytes. So between 0.5 mole per dmq of hydrochloric acid and 2 mole per dmq of hydrochloric acid, which of them will not conduct the highest amount of electricity? So as we've discussed before, the higher the concentration of an electrolyte, the higher its conductivity, or the higher the amount of electricity it will conduct. So mole per dmq is the unit for concentration of a compound. It is the unit for concentration. So like we said, the higher the concentration of the compound, the higher the electricity it will conduct. So the correct answer is option B. Remember, ethanoic acid, they are examples of weak electrolytes, and so they will not conduct the same amount of electricity as hydrochloric acid will conduct. Hydrochloric acid is an example of a strong electrolyte, And from what we discussed before, that the higher the concentration of a compound, the higher the amount of electricity to conduct. So 2 moles per dmq is higher than 0.5 mole per dmq. So 2 moles per dmq of hydrochloric acid will conduct the highest amount of electricity. So electrolytes, like we said, they are molten compounds or compounds in solution which conduct electricity, and they are decomposed at the electrodes during electrolysis. And from what I've explained before, electrolytes conduct electricity because they ionize in solution. So this is the basic reason why they can conduct electricity, because during the process of electrolysis, they will ionize in that solution. So, and like I've said, electrolytes can be a strong electrolyte or it can be a weak electrolyte. So when the electrolyte ionizes completely in solution, we call that electrolyte a strong electrolyte. And when the electrolyte ionizes slightly in solution, we call that electrolyte a weak electrolyte. And examples of a weak electrolyte, we have ammonium hydroxide is an example of a weak electrolyte. Even ethanoic acid is an example of a weak electrolyte. So examples of strong electrolytes, they are compounds that will ionize completely in solution. Examples, we have hydrochloric acid is an example of a strong electrolyte because it will ionize completely. We have sodium hydroxide is an example of a strong electrolyte because it will ionize completely. It will dissociate completely to ions. Then we have tetrasulfate 6 acid, H2SO4. Tetrasulfate 6 acid is also an example of a strong electrolyte because it dissociates completely in solution, or it ionizes completely in solution. Then we have triazonitrate 5 acid, HNO3, is also an example of a strong electrolyte because it ionizes completely in solution. So the strong electrolytes, there are so many: hydrochloric acid, sodium hydroxide, tetrasulfate 6 acid, triazonitrate 5 acid, and the rest. Then the weak electrolytes are basically ammonium hydroxide and ethanoic acid, and we have so many others as well. So let's just look at this question. Which of the following is a weak electrolyte? Which of the following is a weak electrolyte? So which of these is a weak electrolyte? So is it hydrochloric acid? Hydrochloric acid is not a weak electrolyte because it will dissociate completely in water. It will dissociate completely in solution. Sodium chloride is not an example of a weak electrolyte because it will ionize completely in water, so it's not a weak electrolyte. Triazole-95 acid is not a weak electrolyte because it will completely dissociate in solution, to ionize completely in solution. Then ethanoic acid is an example of a weak electrolyte because it will not ionize completely in solution, it ionizes slightly. So this is the correct answer to this question. Which of the following is a weak electrolyte? So it's actually ethanoic acid. So with this, we are done with this class. In the next class, we will look at the preferential discharge of ions during electrolysis. And the preferential discharge of ions during electrolysis is a concept that explains the ion that will be liberated or that will be discharged at the electrodes during electrolysis. So in the next class, we will look at this concept in detail.